Hello guys and welcome to DataMonk. Since this is the first video, let me introduce myself. My name is Dhruv and on this channel I will be making videos about different data analytics tools and machine learning technologies. This will be beginner friendly videos where I will be using Python libraries like pandas and matplotlib for data manipulation and visualization. We will also be using simple machine learning modules from scikit-learn to build our machine learning model. With that said, let's get to our first video. So guys, as you can see, it is a loan classification web app made using Streamlit and Python and developed via Heroku. Basically, this application will show if a customer is eligible for loan based upon the data provided. But before that, we need to build our machine learning model and train it. Therefore guys, this tutorial will be in three parts. First part will be containing data cleaning and pre-processing. In second part, we will do model building and hyperparameter tuning. And in the third part, I will show you deployment of the web app using Streamlit through Heroku. So guys, the datasheet for this particular machine learning model can be downloaded through the analyticsvidya.com portal. This link will be provided in the description also for this video. So the first thing which we need to do after downloading the datasheet is we need to import the necessary libraries. So first we will import the pandas library. Now this library is useful for data manipulation. After that, we will also be using the matplotlib library. It will be useful for data visualization. So in the next step, I am importing the libraries into the data frame df and df underscore test. After that, I am getting the first look at my data frame and getting an idea about what type of data I am dealing with. So on the first glance, I can see some of the things here about the data frame. For example, we are dealing with categorical variables like gender, dependent, education, merit, as well as some continuous variables like applicant income, co-applicant income, loan amount, etc. One more thing which comes into my notice when I first have a look at this datasheet is this NaN value. Now NaN stands for not a number value, and these type of values can cause a problem for us. Therefore, I will keep a note of this. Now moving ahead, I need to look at the shape of my data frame. So I am using the shape method for this. Now what this shows is that I have got 614 different rows and each row contains 13 different columns, which we also call as features. So as you can see, these are the different features of the data frame. Now taking a look at the none values, I am using the isNull function to check the null values and the sum function to get a sum, the total number of null values. So I can see that almost there are 7 columns which have got none values, and out of those and other columns do not have the none values. Now I will be looking for the unique values. Now why do I need to look for the unique values? So the answer to that is by looking at the unique values, we can get an idea about what are the different categorical columns, and when we talk about categorical columns, how many categories are there in each column. So I am using a basic for loop to look and check for the unique values for all the features. So this is a basic for loop, and as you can see, some of my categorical variables have got 2 unique values, while some have got 4 unique values and some have got 3 unique values. Now I need to convert these categorical variables into numerical values. But before that, the first thing which I am doing is getting rid of the loan ID column, as it does not is at this column is not of any use to us. So first I get rid of the loan ID column using the drop method. After that, I am using the map method to map different categorical variables. For example, male is mapped at 1 while female is mapped as 0, and same can be done for different categorical variables. Now you might see that I am using map method for some variables while I am using the get dummies method for other variables. Now reason for that is, as we can look here, the property area column here has got more than two categorical variables. Therefore map method cannot work here. So I need to make dummy columns out of this data, out of this column. So after making the dummies columns, as this will give me the dummies columns, I will concatenate these columns to my original data frame and then drop the actual property area column from my original data frame. Therefore basically what we are doing here is, first we are getting the all the dummy columns from the property area data frame. We are adding them into our original data frame, and after that dropping the same from our original data frame. And the same process can be done for other columns as well. So now after that we get the idea about how will our data frame look. So as you can see, this data frame has got some additional columns like rural, semi-urban and urban. Now these are the dummies of our property area columns, and as you can see, since we used the drop method for property area, our property area column has been removed. Same way 0, 1, 2, 3 and 3 0, 1, 2, 3 plus are the dummy columns for dependent column, and the dependent column itself has been removed from the data frame. After that we need to check at uh, the value counts and see how different column have got the values distributed in them. So I am writing a simple function here to check the value counts. So the first thing which I am looking here is I am looking at the columns for which I need to check the value count. So the columns which I have picked here are the columns which contain the null values. So if you can recall, we had checked if what are the columns which have the null value. So as we can see here, gender, married, dependent, self-employed, loan term and credit history are the columns which have got null values. So I am making a small list of all these columns. But if you notice carefully, the column dependent is not listed here. The reason being that is the column dependent has already been turned into a data frame into its dummies, and we have dropped that dependent column. Therefore we do not worry about that column. Now after that I am using a simple for loop to run through each of these features. And when I run this for loop, I get the output like this. Now this might look scary at first, but let me break it down for you. So what I am printing out here is, first the value for the loan status for column loan amount for value 1 are are 120 17 times, 110 12 times, 100 11 times, 130 10 times, 187 9 times, and so on and so forth. So basically what I'm trying to say here is, if we look at the loan amount column, then for the value of loan status equal to 1, it means for the situation when the loan was approved. In that case, the distribution of the data for the loan amount column is as follows. So as of now I cannot see any pattern here. Now let me go ahead. I also need to check what is the condition here when we look at the situation when the loan wasn't approved. Therefore the loan status was equal to 0. So this is a very important step, guys. We need to look at all the columns in both the conditions, since our data can have different insights when we take the condition of the loan status was approved and the condition where the loan status wasn't approved. So this is the very tricky step, and we need to keep in mind when we are doing a classification type of problem. If it is a bivariate classification, then we will have two condition. If it is a multivariate classification, means there are more than two outcomes, then we might have to run this for all those outcomes. So let me check. The same has been done for the loan amount term. Now for the loan amount term, I can see that a huge number of entries are 359 entries have been made for loan amount term as 360, while the others are quite less. So I can safely assume that for the loan amount term, I can substitute the value 360 wherever I find the null values. Similarly, for the loan Similarly, for the column credit history, most of the values are there are 378 which are 1, which shows that most of the cases, the when loan was approved, the credit history was 1, means it was good credit history. Now that seems logical also, because credit history, as we know, does play an important part when it comes to loan applications. Now, when we talk about the situation when the loan was not approved, in that situation also credit history is the credit history has value 1 for majority of the cases. Therefore, here also I can safely assume that I can substitute 1 for the non values in the credit history column. Now talking about similarly looking at the self-employed column, you can see that here 0 has been coming more number of times, that is 343 times 0 is used. Therefore I can do imputation and replace the null values with 0 values. Same way talking about gender, I can replace the null values with 1 value. Now as you can see here, the only see, the only variable which I haven't got idea about what we can do about the null values is a loan amount variable. Since this is a continuous variable, there are some other methods which you can use. For example, I can look at the median uh, of the loan amount value. So the median comes in at 128, and if I look at the mode of the mean of this value. Okay, so for loan amount, the mean comes at around 146. So since the mean and the median do not have huge difference, we can safely impute the values. We can safely use the median values to fill the null values for the loan amount. So as you can see here, I am replacing the values with the appropriate values as discussed ahead, as discussed before. So the gender is replaced with 1, married with 1, the loan amount term with 360, and the credit history has been replaced with 1. So guys, after that we will have a look if we have missed any type of null values here. So as we can see, all those columns have got 0 null values. Now there is one last thing which we need to look here. I need to check if there are any outliers in our data model. Now, outliers can, give some trouble to us and can make our model work in erratic way and give us not our desired results. Therefore, I will be using a simple box plot, which is through our matplotlib module, which will help us to look at the null values. So I am using the subplot function here since I want to look at 4 different box plots of 4 different features in one go. So I will be using the box plot function and using the title method so that I can differentiate between different box plots. So after running this simple function, I can get an idea about the outliers. Now as we can see here, if we look at the applicant income after about the value of 2000, we can see some values are exceeding up to 80,000. So these are the values which we call as outliers. Now if you want, you can also look at values between 10,000 and 20,000. Now I will also tell you how we can decide about what to do when we have situation where the 10,000 similar situation where values between 10,000 and 20,000 are also there, and after that even more than 20,000 I can find some values. Same way, looking at co-applicant income, I can see that after 20,000 there are some values, a handful of values which go up to 40,000. So it looks like values. If I impute the values greater than 10,000, I won't be losing much of the data, and a lot of my outliers will be solved. So we're looking here, we can see that 500 looks like one outlier which we found in loan amount term, so I can get rid of that. And here, talking about the loan amount itself, there are some outliers, but I feel 400 seems like a good estimation since there is a huge cluster here. So any values greater than 400, I feel can be imputed. So let us have a look. Talking about applicant income, as we said, let me see how many values are greater than 20,000 here. So instead of will using a simple log function is basically a locate function which locates the values of the data frame with a particular condition. So for example, here I am using this condition, so where the loan amount is greater than 300. Let me try 400. So give me all the rows in which account account of all the rows where the loan amount value is greater than 400. So let me run it. Okay, so it looks like there are around 14 rows which have got loan amount value greater than 400. Now if we use 300, let me check. Okay, so there are almost double. So I feel I am little bit comfortable here to going for 1400, so that out of around 600 values, um, I won't be having much of a data loss, and I will be getting rid a lot of my outliers. Therefore, I will keep that in mind that for loan amount the value should be 400. Or we can do here is in uh, copy this drop method, and for that loan amount we can put it as 400. Now I will show you how this drop method will work and what I have done here. Not to worry about it, but as of now, our first priority is to come up with the values the boundary points from which we want to impute the outliers. So talking about the applicant income, as I said, 20,000 looks like a good estimation. 10,000 also looks like a good estimation, but I am inclined towards 20,000. So let's have a look. So I will first copy my feature name and the value. As I said, let me see how many values are there greater than. So there are almost 12 rows which are greater than 20,000. Now talking about 1,000 or 10,000. So, okay, so we'll be losing more 40 column if I increase my margin from 10,000 to from 20,000 to 10,000. So I'm not comfortable in losing so much of data. Therefore, here I will be going for 20,000, since there are only 12 values which I will lose, and also I will be getting rid of most of my outliers. So for applicant income, as it is written here, 20,000. Now same way, talking about the co-applicant income. For this, 10,000 looks like a good estimate. Still we shall have a look here. Okay, so only 6 values are there. So I feel 10,000 shall work. Okay, so no need to check here. It looks like a good option. Same way, talking about loan amount term, as I said, anything greater than 400, we just have got one outlier, so that won't be an issue. So I can directly drop that value. So as I said, it is a simple drop function which I used before also, but here there are some conditions which we are using. For example, I need to drop the values for in the data frame of all the columns which have got my loan amount greater than 400. So first I am using log method to locate all those columns, and then I am dropping them. But what I am doing, one more thing, is I am using x is equal to 0. The x is equal to 0 stands for all the rows, while x is equal to 1 stands for all the columns. So here I will be dropping all the rows, and the same logic is applied for all the commands here. Now in place true stands for so that I need to make the changes in the data frame itself. Therefore I am using in place is equal to true, so the changes will directly reflect inside the data frame. So after running, successfully completed our goal for cleaning our data, our model, and after that we will be exporting our data frame into the data cleaned CSV. So guys, that is all for this data cleaning part. Now I would highly encourage all of you to do the same imputation process and clean the and test data frame as well. You can change some of the parameters depending upon the type of outliers which you come across, but more or less these conditions shall also do the job for you. But you can always try and see and come up with different ways about data cleaning. If you found this video useful, guys, drop me a like and follow Datamonk on Instagram. Also subscribe for more such awesome videos. Talk to you guys in the next one.